Today's assignment is 203A, 1 through 19 odd. Now it appears as though there are only 10 questions, but each question has multiple parts, none of which is difficult. There's really only one thing we need to, well, a couple things we need to review, but you probably forgot how to compose functions, but it's easy. Take a look at number 2. We'll do number 2. It's not one of your functions, but that's okay. 203. Two oh three, 1 through 19 odd. Everybody got that? Okay. So, number 2 gives us two functions, 3x plus 2 and 3x minus 2. The instructions say, given the functions f and g, find f plus g, f minus g, f times g, and f divide g, and state the domain of each. So, f, whoa, one of these days I'll remember that. F plus g of x is simply f plus g. 3x plus 2 plus 2x minus 4. If I add those together, I get 5x minus 2. What is the domain of that function? Well, I have this nifty little graphic. So down here, in general, the domain of a composition will not allow any values restricted by the domain of the starting function, along with any values whose answer from the starting function will be restricted by the second function. Now, that's for compositions, but which we'll get to in a second. In general, nothing in the domain, none of the domain restrictions in the original function, all of the domain restrictions in the original function and all of the domain restrictions in the second function still remain. Okay? So if we look back at these, is there any problem with the domain in F? No. What are we looking for domain restrictions? Square rooting negatives and dividing by 0. So neither F nor G have any domain restrictions, and adding them together doesn't create any other domain restrictions. So the domain here is simply all real numbers. Okay? The next function, f minus g of x, is simply f minus g. So 3x plus 2 minus 2x minus 4 turns into 3x minus 2x is x. 2 minus negative 4 is 6. Do any of those three have any domain restrictions? No. So the domain would be all real numbers. Okay. F times g. 3x plus 2 times 2x minus 4. What do you get when you multiply those? So f times g is 6x squared. That one gives me negative 12, and this one gives me 4. Negative 12 plus 4, negative 8x minus 8. Any domain restrictions there? Do we divide by 0 or square root negatives? Nope, not a problem. And then f over g, I hope Cynthia's nice to us here. It's simply 3x plus 2 over 2x minus 4. That can't simplify it all. You could pull a 2 out of the bottom, but it doesn't cancel anything in the top. That is the function. Does it have any domain restrictions? X is not allowed to be 2. I set the denominator equal to 0, add 4, divide by 2. X cannot equal 2, or we end up dividing by 2. Okay, now I want to do one that is in your set, just because sometimes Cynthia tries to be smarter than the rest of us. Number 9. So number 9, the first function, the addition function, is the square root of 4 minus x plus the square root of x plus 3. Number 9. When can you combine square roots? Using addition. When the roots are exactly the same. So if you had like 6 root 3 plus 2 root 3, you end up with 8 copies of root 3. But in this case, the roots are different. That's the function. That is the function. Now, what about domain restrictions? What are the restrictions here? Well, just think about it. What numbers can you not plug in? So, negative 10, is that okay? 4 minus negative 10. That's 14. Can you square root 14? Yes, that's not a problem. What numbers do create problems? So 2, positive 2. Is that a problem? 4 minus 2. Nope. Anything bigger than positive 4. And in general, what we do is take the stuff on the inside and say it has to be greater than or equal to 0. So 4 minus x needs to be bigger than or equal to 0. We could add the x. 4 is greater than or equal to x. Or you could subtract the 4 and times by negative 1 and flip the inequality. So here, x has to be smaller than 4. But on the other side, x plus 3 has to be bigger than or equal to 0. When we subtract 3, x is greater than or equal to negative 3. So together, the domain would be negative 3 with a bracket. Yeah. So the domain of the addition function is from negative 3 to 4. Everything in between those two values, including those two values, works in both sides. Okay? The subtraction one is really tough. There it is. What about domain restrictions? They're the same. Right? By changing, putting a subtraction in the middle, the domain restrictions are the same. So that's the subtraction. So what? It wasn't hard. I was joking. That was my joking voice. Yeah. Okay. What about the multiplication? The square root of 4 minus x times the square root of x plus 3. How do you multiply two square roots? So if I had the square root of 20, well, let's do something smaller. The square root of 12 times the square root of 8. As long as the number of the root, the version of the root is the same, you just multiply the stuff on the inside. So this would be the square root of 72. So here, it's just the square root of whatever 4 minus x times x squared plus 3 is. So that would be negative x squared. So x squared, and then that would be plus 4x minus 3x is plus x minus plus 12. Okay? Well, I know what the factors are for that. Right? They're 4 minus x and x plus 3. So, what is the domain of that? It's the same, right? Thanks. Let me check the back. Right? Without doing much thinking, it should be the same. We're on 203, number 9. What does Cynthia say? Negative 3 and 4. From negative 3 to 4. It's the same numbers. Okay? The division one is just slightly more complicated. And that's true. No, not my joking voice. So the square root of 4 minus x over the square root of x plus 3. Now, depending on how complicated Cynthia wants to be, what's the domain of this? Before I change it, because I'm going to change it here in a second, what's the domain? It's the same except for one thing. It can no longer equal negative 3. This portion of it is no longer true. Why? If negative 3 is plugged in, then we get the square root of 0 in the denominator, and we end up with dividing by 0, which is an issue. So the domain is going to be negative 3 to 4 in that manner. We just threw out negative 3. Okay? The other problem is, I assume Cynthia does not want us to leave that square root in the denominator. Is that true? What does the answer say? Not that. So, anytime you have a square root in the denominator, we do what is called rationalizing the denominator. We're going to be doing this a lot. Luckily, there's not a lot of work involved because we already know what the answer is. Wait, let me see. Well, that's even easier. So you multiply by x plus 3, square root of x plus 3, and square root of x plus 3, which on the bottom, the square root cancels. And she doesn't usually do this, but she's nice. She just leaves it like this. But multiplying them together is not difficult because I already know what it is. It was the answer previous, but she left it like this. So we'll leave it like that. How nice of her. Okay, last one is composition. So let's do number 17. Composition, F composed with G of X and G composed with F of X. A couple things I want to point out. Composition is an operation that only exists with functions. You guys understand addition, subtraction, multiplication, and division. Those are just rules of how you combine things. Okay? We can add numbers, we can add functions. Composing is a function-specific operation. So there are 5 operations when it comes to functions. Composing means plugging one function into another function. Okay? The symbol for that is a little open circle. It's different from multiplication. So F times G would look like that, but F of G is that little circle. Okay? So multiplying and composing are 2 different things. In fact, if I were in charge, I would never write it that way. It just doesn't make sense. I would write it this way. F of G, which essentially says G gets plugged into X, and then, X gets plugged into G, and then G gets plugged into F. So F of G of 1 simply means replace the X and G with 1, and whatever you get, plug that into F. Composing function works like this. If we have F, F can turn the number 1 into the number 6, and this is the range of F. It's also the domain of G. We take 6 and we plug it into G, and it turns into, say, 3. So if you take all of the domain of one function, plug them in, find the ranges, take those ranges and plug them into the second function, then that's how composition works. You use the answers from the first one to plug into the second one. But the composition skips straight from 1 to 3. Okay, hopefully this is a little bit of a review. I'll show you how it works. So number 17, F of G. f of g really just means g stuck inside of x. So it's a little bit backwards. You take g and plug it into x. So I take this, and I stick x plus 5 everywhere I see an x. In this case, there's just one of them. But if it was a quadratic, like x squared plus 2x plus 1, every x would become x plus 5. So I stick this in here, and I get the square root of what used to be x is now x plus 5 minus 1. Okay? So f of g of x is the square root of x plus 4. Does that make sense? I just did x plus 5 minus 1. I just simplified. Okay? Now what does f of g do? Well, let's look at, I'm going to pick a number. It's not going to be a good one. I'm just going to guess. Let's do f of g of 6. What happens when I plug 6 into g? When I put 6 in there? 6 plus 5 is 11. Now I take 11 and I stick it into f. What happens when I put 11 in there? I get the square root of 10. But the new function will go straight from 6 to 10 and skip the middle. So if I plug 6 in here, 6 plus 4 is 10, and I get the square root of 10. So basically, this is what's happening. G turned 6 into 11, and f turned 11 into 10. But f of g went straight from 6 to 10 and skipped the middle. Okay? Now what about domain restrictions? And this gets a little bit tricky. Even I get confused sometimes. All of the domain restrictions are preserved. If there are any domain restrictions, they're preserved, plus the new function might have domain restrictions on its own. Okay? So, looking at the original functions, and if I mess this up, I'll try to explain it in a different way. Does g have any domain restrictions? No. Does f have any domain restrictions? Yes. X must be greater than or equal to 1. Does the end function have any domain restrictions? Yes. So I have x needs to be greater than or equal to 1, and x needs to be greater than or equal to 4. Negative 4, sorry. So, what does the back say? No, 0 is okay. Squaring 0 is okay. It's dividing by 0 that's the problem. Yep. Let me see. Okay, so this one includes everything. So that's just, this is where I think I disagreed last year. So, okay, here's our picture. Be sure that the answers coming out of the first function can be picked up by the second function. If the answers cannot be picked up, the answers creating that answer is not in the domain of the composition. So we look here. The original has no domain restrictions, right? So looking at the answers for that, which answers of that can be plugged in here? Anything but anything that eventually creates 1. So this is a little bit tricky. You guys might want to watch this. So which answers here cannot be plugged in there? Everything goes into G, right? But sometimes when I plug stuff into G, they end up creating problems in F. Oh, there's a door over there. Sorry. Come on in. I'm almost done. I locked you out. We're just about done. Okay. So, which numbers here create problems there? These. -4 plus 5 is 1. And when we plug 1 in, it's okay, but anything less than 1 is not okay. Does that make sense? So we'll go back to our picture. We have to look at what can be plugged into the first function. Nate, you want to watch this? So you have to look at what can be plugged into the first function. Those domain restrictions are preserved all the way across. But sometimes things that work in the first function end up not working in the second function. So in general, the domain for a composition will not allow any values restricted by the domain of the starting function, along with any values whose answers from the starting function will be restricted by the second function. So there are two parts to it. If it doesn't go into the first function, it's out. If it goes into the first function but then creates problems in the second function, it's still out. So in this case, everything goes in here, but if we plug in -4 or smaller, then those answers create problems in the second function. Does that make sense? So the domain of the composition is all of the restrictions that the first function has, plus any restriction that's created when you go from the first to the second. Okay? And if you look here, these numbers are not allowed to be plugged into the first function, but we said that the ending domain is this. So there are a whole bunch of numbers excluded there that are included here, and the reason is because the numbers coming out of the first function, these are not an issue. I don't know how to explain that in a better way, but maybe to try it again. So let's do it the other way. G of f of x. That means we take f and we stick it into G. F and we stick it into G. So this goes here. So that's the square root of x minus 1 plus 5. Does the original have any domain restrictions? X has to be bigger than or equal to negative or positive 1. Okay. Now, do any of the answers coming out of there have additional domain restrictions? No, we're just adding 5 to it. So that doesn't create any new ones. So the domain here would be from from positive 1 to infinity. Okay. Give that a try. It's not as bad as you might think, but that domain and range gets a little bit tricky. So give it a try, and I'll answer any questions that you have. Good luck.